Hi, in this video, I'm going to do a short introduction of the XPL2 programming language, which is the programming language we are going to use in the CVC. Help is very extensive in the CVC, so all documentation can all be found in help contents. So information about programming can all be found after the keyword my namespace. Okay. All information on programming language can all be found in this help file. Alright. At the start of the help file is getting started, where the CVC IDE will be introduced to you. Alright. Next, the versions for all the IPQ firmwares, touch banners, will be listed here, with all the bug fixes available for each and every firmware that has been released till now. Terminology used in the CVC help is also explained here under the terminology section, where we will explain to you the various terminology used in this system. For example, API stands for Application Programming Interface, and the full explanation is an interface that defines the way by which an application program may request services from libraries and operating system. Alright, so the other parts of the APIs and other aspects of the various terminologies can be all found in this section. So you can actually browse through the section and find the various information on the terminologies used in this software. IntelliSense will attempt to sense the complete commands that's needed by the programmer when the programmer is typing and writing the codes. So this will actually ease programming by reducing the number of key entries into the system during programming. So you can complete word, you can complete constructions as well. These are examples of how the system works to complete a word or complete a construction when the users key in certain characters or certain names pertaining to the system. Topographic conventions are also shown in the help file. Using the keyword my class will actually refer to the functionality and the variables defined in my class. Similarly, my common keyword will explicitly define a constant or function or a class that's used in your module defined in the my common module. So each and every keyword has its own unique functionality and reference. Programming and module. This will actually show you how to program a module. These are sample codes that shows a module. And a module can be a graphic module. It can also be a device module that is actually a device driver that you have created that actually talks to a third-party equipment, like the Bravia TV example that has been shown previously. The auto-execute process can only be contained in one of the modules in the system. So this process must be unique, and usually this auto-execute process will be contained in the main module. Init is a function that when declared in a module will be executed when the module initializes, and it will be executed at the start of the system before the execution of auto-execute, which is a process. And various keywords used in CVC are also explicitly named in the help file. Commands is denoted by a double slash in Q, and it could also be between a slash and an asterisk, and closed with a slash, an asterisk, and a slash. So the example of commands are as such. So this is a command, and this is also a command. In CVC, there is a number of constant value that can be declared. Alright, so if there's no prefix, 128 will be equal to a decimal number. Negative 345 is a negative number, and 3.14 is a floating point number. If you put a NH in front as a prefix, 80 will become a number 80 in hexa. And NH in front of 2400 means that it will be 2400 in hexa format. It will not be 2400. The value will be different. If you want to test it out, just open up the Microsoft calculator and press in 2400 as hex and convert it into a decimal, and you will get the actual decimal value. And when you put a NB in front, the numbers following will be zeros and ones, denoting a binary number. Time constant. Time constant is denoted by a hex at the front and at the back. And time constant may include only time. Alright, it could be hour, minute, seconds, and milliseconds. It could also be minute, seconds, or just seconds, or just the milliseconds. It could, and full time can also be with date and the time at the back. This is an example of date and time together. Character constant value is denoted by a single quote, a single apostrophe at the front and at the back. A text constant is denoted by a double quote at the front and a double quote at the back. And the middle contains the text. As we are using keyboard for programming, there are some special or non-printable characters that you need to use. And to key in the non-printable characters, what you need to do is to put in a slash in front and a unicoded character at the back to denote a special character. Slash 000A denotes a new line or a line fit character. And finally, we have the byte string constant value, which is denoted by NS in front and with an open double quote and a closed double quote at the end. And as the name implies, byte string is a string of bytes. This brings us back to the previous value, text constant. Text constant is actually a text constant. The difference between text constant and byte string constant value is that text constant may contain Chinese or any other Unicode characters, whereas byte strings must contain only pure ASCII characters or non-printable byte strings. So in the CVC context, data to be displayed on the touch panel are text, and data to be used to communicate with third-party equipment are all byte strings. So for some communication with third-party equipment, data might be coming in a byte string format. However, to display the data, you have to convert it into a text. So there will be functions to allow you to convert a byte string to a text with a parameter for determining which encoding standard the byte string is using for display. We will discuss about that later on when we are running through the functions of byte strings and text manipulation. Identifiers are elements of a program code, and they must fulfill the following conditions. They must contain only letters, numbers, and the underscore characters, so you cannot key in Chinese or Unicode characters into the system as identifiers. However, you can key them into a text constant or in between the open and close double quotes. They must begin with a letter. They are case sensitive. They cannot be keywords. These are the conditions of an identifier. So an identifier, a classic example of an identifier will be the name of the array or the name of the variable to be declared, the name of the constants, name of the functions. All these are identifiers. Operators in the system includes arithmetic, bitwise, logical, relational, assignment, type conversion, and others. So there are many different operators available in the system. I would not go through all of them. Alright, you may spend some time to open up the help and try to run through a few of the operators. Or you may also do so as and when you need to use certain operators in the system. Under operators, you find the documentation or the help for various operators that's available in the system. Arithmetic operators signifies number manipulation operators like plus, minus, multiply, power, etc. Bitwise operators specifies bit manipulation capability of the system, allowing you to shift bits in a byte. You can also do bit AND operation, OR operation, exclusive OR operation, and so forth. Relational quantifies. Relational operators will work with conditional statements or loops. And is mainly to be used in relational is usually used to under logical is also used in condition, but different from relational in the sense relational contains operators like equal, where it can be used to relate to different variables or different constants. Whereas logical is used to do logical calculation or logical condition between two Boolean variables or constants. Assignment. This is a single assignment to actually assign a number or a value to a variable or constant for that matter. So there are various other assignments as well with the built-in ability to do some arithmetic operation or bit manipulation operation within the same assignment operator. This will help you save the number of key press needed to create the function you need. Type conversion. These are actually type conversion for numbers, converting the number to a double or a long variable. Others include address of operator, raise event, start process, stop process, and variable of. Alright. The detailed functionality of each and every one of these operators are all shown in the help file. You may take a look at it as and when you need the functionality. And the precedence of operator are also shown in the help file. Precedence means that the operators will be executed based on the level of precedence for each operator. Under accessibility, we have got 4 different types of accessibility keywords, namely private, public, global, and protect. Private will be used in a scenario whereby you do not want the function or variable to be accessed by other modules outside the module in which it was declared. Public function will be used if you want the function or variable or constant in a module to be used in another module in the same device. However, if the function, constant, or variable has been declared in a module that is residing in another device, let's say you have a touch panel and a controller, and you want to execute a public function in a module located in a controller. You will not be able to do so because public keywords only allow access within the scope of the device itself. So you can actually call the function in another module that is made public if the function that you are calling it from is also residing in the same device. To access functions in another device, you will have to declare the function as global. So global allows accessibility across all modules and controllers and touch panel in a device. Any protected function or variable declared will be able to be inherited by a child class that inherits a parent class containing a protected function and variable. Protected is a special accessibility keyword. It is usually used, or rather, protected is a special accessibility keyword that is used only within a class. Reason being is that it is declared and used as a function or variable that can be inherited by a child class. It can be shown in this example here, whereby we have created a parent class with a protected variable x and the function clear. The function do something is also declared, and this do something runs the function clear. When the child class inherits the parent class, you realize that you can also run the function called clear, because the clear function is inherited into the child class from the parent class, and the variable name x is also available. So this function set to 10 will be valid. But however, if you have declared in the parent class, if you have declared the variable x and the function clear as private, you would not be able to use this function in the child class. So this function is mainly used for inheritance. You might ask, what if I declare the two functions? What if I declare the clear function as public and the variable as public? But this way, if you declare the two of them as public, when you are using the parent or the child class, as you can see here, if you try to do a parent.x, if the parent's x variable is declared as a protected variable, this command will not function because the variable will not be accessible outside the class. So protected is a special keyword. Under this protected keyword, a child class can inherit the functions and variables that is protected. But when the child or parent class is used by another module, the protected functions will be locked away from that module, which means that it will remain hidden by the protected keyword. And so this keyword is mainly used for inheritance. Data types available by this system. We have got various data types that's available in this system, namely Boolean, which is a true and false expression, which it can only contain two conditions, true or false. Byte will be any number between the range of 0 to 255. Long, a big range of number, as shown here. Double, a floating point number that is ranged from the following. Time, in the following syntax shown here. You can also define time as interval if you leave out the open and close hex character. Character, text, and byte string. Alright, other special data types is anything. Anything, as the name implies, it may be a text, a long, or any data type. But however, before you can use a variable of anything, you have to cast it or assign it to another variable of the type above. Alright, it must be retyped to another type of long, of text, or byte string. Please, for the usage, you may see the example here. So you have a variable called anything, and you have a variable called long, and text variable. And the first command, assigning anything variable to number 1, 2, 3. But however, you cannot use anything variable directly for display. So you have to assign anything variable back into a long and debug print the long variable. Debug print will print out the content of the variable onto the debug window in the IDE. So the next example, you assign the hello text into anything variable, and the same thing, you assign anything variable back into a text variable and you display. The result on the debug window will be 1, 2, 3 followed by hello. Array. Array is a list of numbers, and I believe for most programmer, you probably know what an array is, so I will not go into details. But for more information on what's an array, please look through the help documentation in CVC. And num, in short, enumeration, in short, and num is a listing of enumerated items proportionally to their values. Alright. So this is also similar to the enum functions in all other languages. Similarly, we have also got structure, which is quite similar to a record in C language. And to know more about classes and inheritance, under data types, there's another section called class, which give you full samples of what's class and how inheritance work within a class, and what is the keyword friend, and so on and so forth. And the function init, when used inside a class, will be executed automatically when the system loads. And the use of me, and the type of class available, like the other class available, like device class, and finally graphic classes. Next are constants. This area shows you a good example of the various constants you can declare in the system. Variables on how to declare. Variables. Property. Property, when used inside a class or device driver or graphic collection, will be shown in the property section in CVC. So properties are actually variables inside a graphic class or device driver that can be used and set by the user when you do programming. For a detailed read-up on the properties, please go through the documentation here. It's a short write-up on properties. We have also got functions in CVC, and for functions, we have two types of functions, a function with return value and a function without return value. Alright, the difference is, for a function without return value, the declaration of a function is simply function, keyword, followed by an expression, alright, followed by the declaration of the parameters, and followed by a close bracket. At the end of a function, to end it with an end function. To do a declaration for a function with a return value, you have to add a s return type at the end of the function, and the return type can only be of Boolean, byte, character, double, long, or time. You may also see the sample here on the function. Processes. Processes are actually similar to function in the case of declaration, except that the keyword has been changed from function to process, but the usage of process is different from function. What's the difference? Process has to be started with a keyword called start process. And with this keyword, the caller to the start process will actually spin off a new process or a new thread to handle the process. So what this means is that when you have the process called auto execute here, when executing this, when he executes the start process keyword, read data will start running, and this process called auto execute will actually run through and terminates. Read data will continue running until the process completes. What does this mean? This means that process is actually a feature that is quite similar to the multi-threading feature of other languages. So Q is actually, in a way, a multi-threaded language. Alright, these are all samples of how to use processes. And process can also be linked, alright, by an object, or it may be a graphic object, or it may be a device driver. An event creates a linkage between a generated event and the subsequent handling of the event. When an event is generated, an appropriate function is called or process is started. The function or process contains the handling program code for the event. So this is the functionality of the event. And the QCVC is a fully event-driven software. You will realize that when the user touch a button on the CVC software, an on-push event will be generated. And as handling of this on-push event, you may trigger a volume up command on a device. And when the volume up command has been sent to the device, a volume change command might be sent back from the device to the controller as feedback. And when the controller receives a volume change command, it could raise a volume change event on the device itself. And as handler for this volume change event, the panel may update a bar graph on the panel to reflect the new volume on the device. So this classic example shows how event flows from the user's panel to the device, and from the device back to the user interface. For more function, for how to declare events and more examples on how event works, you may refer to the help here. Parameters. Listed here are all the parameters that you can use and how to declare the parameters. You may also declare an array of parameter, and also shown here is how to do that. How to use a parameter array, which is an array of parameters that can be used for different types of variables. Alright, or rather, parameter array is a group of parameters to be passed to functions and processed at the parameter position, at the parameter array position. The CVC also supports param array as an array of parameter for functions. For more information about param array, please refer to help. Next, we have a list of all the control construction available in CVC. If then else statement. Select is also available as select case statement. Do while. We do not have while loops, but we have do while loops, which is actually similar to while loops in C language. We also have a do loop configuration, a do configuration without a condition at the end. An exit do can be used to break out of the loop. A for loop is also available. And finally, go to. For this, I have run through a brief introduction of the XPL language syntax. In the next session, we are going to cover the XPL commands you can use for programming drivers and graphic collections. Next is structure. Structure is a data type that contains one or more variables in one object. A structure is actually quite similar to the keyword record in C language. Next, a function. Let's move on to the next. Functions. A function is a part of a program that can be repeatedly called from a diverse location of a program. It's mainly used to create a block of program or code that will be repeatedly used within the program, so as to reduce the number of lines of code and to make the program more efficient by doing some summarizing. For example, there are actually two types of functions: functions with return value and functions without return value. These are actually examples of a function without return value. For example, the get temperature message function features two parameters, a temperature parameter as the variable type long, and by ref a message as text. By ref means by reference. This means that the variable that is passed into the function will be a reference to the variable that from the variable of the calling process or function. So, when you change the content of the variable inside the function, the content of the variable that is linked into the system from the caller will be actually changed as well. So, for example, if the function works this way, if the temperature that you pass in is less than 80, then the message will contain increased temperature, or else the temperature contains that temperature is okay. So, by the condition here, the message will store either increased temperature or temperature is okay. So it will store either of the message depending on the temperature that is passed into the function. And this way, the function is able to return a value without declaring a return value for the function. Secondly, a function with return value. So this example below shows a function with return value. The function name is called average temperature, taking in two temperatures, temp1 and temp2. So to return the average temperature, you return the value temp1 plus temp2 divided by 2, which is the average of the two numbers. And the return type is in the same type as a byte. So this function will actually return a variable that is of type a byte. And the variable that's going to, the value that's going to be returned is actually the two temperatures divided by 2. So this is the function with a return value. Note, however, for functions with return value, the values that can be returned are only of Boolean type, long type, double type, and a reference or address. So basically, the return value cannot be a complicated type like a byte, like a string or a byte string. It can also not be an array, but it can be a reference to an array, or it can be an address to an array, or an address of a class. So this is the functionality of a button with return value. Process. What is process? A process is a code, is a set of code that operates in parallel to a function or process that started it. So it's like the fork command in C language, or the multi-thread, or rather is a thread in Java. So a process can only be activated with a start process command. So this is a sample with a process with parameter, having the process called read data, taking in two parameters, minimum min valid, max valid. So when this process auto-exec wants to start the read data, it has to put in the keyword start process and putting in the parameters. And hence after, when the this is how the execution works. When the system executes auto-execute, it will run start process read data, and after that auto-execute will terminate. And read data will continue running until the process finishes. Or in some process or certain process, it might be an endless loop process which continuously pull apart for data. Alright, so it may be a service process that is running in the background, and it will not be stopped at least until the system terminates. Another example of a process is a linked process, and this process may be triggered by an event in the system. For example, page 1, push button 1 on push, means that in page 1, push button number 1, and when the button is on push or being pushed, this event will be triggered, and the process will be as listed in between the two process line. So you can actually put commands in this process, and when the on push event is triggered, when this process executes, the commands will be processed and handled. So this is the example of a linked process. So process can be started by your own codes, or it may be also started by events. So next, events. Events create a linkage between a generated event and subsequent handling of an event. An event is actually a happening in the system, and the event can be linked to two types of handling event handlers, namely a function or a process. As we have mentioned earlier, the difference between a function and a process is that a function, when called, will be executing within the caller's execution space. And whereas a process, when started, it will create its own process space and execute within its own process space. In fact, all execution in queue is by a process, one way or another. So when a button is pressed from the touch panel, a process will be triggered, and this process will also trigger another process, which may in turn trigger other process. Alright? And this process may also call functions, but however, when it calls a function, there's no new process triggered, so the function will terminate and return a value to the process, and the process may go on executing. So for example, this is a driver code of a process without parameter. An event has to be declared in a module or class. So for example, there's a graphic class called push button, and the event that is going to trigger is on push. And how it triggers on push is that when the button is released, which means that the button has been pressed, okay, and released, we will raise an event called on push. Alright, so what this means is that when the button is being pushed, an on push event will be triggered by the system. And the event type is a process. So how to use the driver when it's inside the CVC module. So a private process by the name of page 1 push button on push is created with a link to the event called page 1 push button 1 on push. Alright, and this event will be triggered whenever the button is pushed from as shown in the driver code for a process in example 1 above. So this is roughly how an event works. Parameters. A function and process parameters can be declared using the type, okay, and it can be of any data type as shown in the previous slides. The syntax for the parameters is optional, followed by value or by ref, followed by the name of the parameter and the type of data. If it is by optional, you have to put in a default value. This means optional means that the parameter can be optional. And if it is not passed in, which means that the parameter may or may not be used. If it is not used, the default value will be stored into the parameter as the value of the parameter. So this is the use of the default value, to be used only with the optional parameters. You can also declare an array of parameters, and you can also declare a parameter array. Array as a parameter is to put in a parameter of an array of a certain type. And size of dim is used to detect the size of the array that is being passed in. So this will give you some ways of knowing how many parameters or how many array of a certain type has been passed into the function or process. Another type, finally, the last data type, or rather the last type of parameter is a parameter array. Parameter array is actually an array of parameters that is of any size. For example, here the second parameter of the function named concatenate text is a parameter array. So when the parameter array position are passed in more characters, the system will actually concatenate all the characters together and put into the first parameter. So for example, we have here declared a variable called first name with the text Peter inside, and the result as text with 100. The box here implies the size of the text is 100 characters. So the function is being executed result with hello, first name, and how are you passed in. So when you print out the results, you will get hello, Peter, how are you? So hello is concatenated with Peter as it is stored inside first name and followed by the constant how are you. So these three texts will be concatenated together, creating the final text. So with this command concatenate text, because the second parameter onwards is a parameter array, you can put in any number of text values and the end result will be concatenated into the result variable. Next, in the XPL2 system, in the XPL2 language, we have a few control constructions that are available for you. Although you'll find that the control constructions are maybe less than what is available with other languages, but this control construction will be sufficient for you to do any project or any type of programming. We have got the simplest one, if then else statement. which is formatted by if followed by an expression, condition expression, then followed by some commands, and followed by else if some expression again, then followed by some command, followed by else, some commands, and end if. So this is a classic example of the if then else statement. Similarly, we have also got select case statement, while do, and do loops, and do while loops, and do and do loops, and do loops will simply continue looping until the exit do has been executed inside the system with a certain condition. So do loops are actually for endless loops that does not easily end. We have also got for and end for loops, which is actually signified by the start and end statements, which is usually used by a counter. So it may be for counter expression 1 to 10, and then followed by end for. And finally, we have also got another expression called goTo, followed by a label. Note that this goTo command is not recommended to be used in a structured language environment. This feature is built in for you to use to do some simple shortcuts as needed, but you have to be careful when using the goTo command, because goTo commands will make your program less difficult, or will make your program very difficult to troubleshoot, because of using goTo. When you are using goTo, the program execution will actually be jumping. Okay. goTo will actually cause the program to be a lot more difficult to troubleshoot than other control constructions. Please do take note of that. Operators. We have various operators available in the system. For more information about operators and control constructions in the previous slides, please do look through our help. We have for operators, a brief introduction. We have arithmetic operators for operating on the numbers, featuring plus, minus, multiply, or even power. We have bitwise manipulation commands or operators, featuring bit end, shift left, shift right, etc. We have relational operators that is being used for conditions, logical operators for Boolean operations, assignment operators to assign a value to a constant or variable, and other type conversion operators like C-long, C-double for numbers conversion from double to long, long to double, etc. And other operators includes address of, variable of, for getting a reference to the variable, or an address of variable of to get the variable of the reference. Alright, start process, end process, etc. Next, classes. Classes in the XPL2 language, we have three types of classes: class, device class, and graphic class. Namely, class is a standard data type which combines functions, variables, and processes into one object. Device class and graphic class are similar, except for device class. It is used mainly for creation of device driver. Each device driver is actually a device class. And graphic class is usually used for the development of graphic collection or graphic objects. A button, a push button, or a window is actually a graphic class. So syntax of a class may include as follows: class followed by class name, inherits a parent class if any, and it can also contain friend, constant variable declaration, functions, and functions init declaration inside the class. When you declare a function called init inside a class, this init will be executed when the class is loaded into memory. So this will be an initialization, or in Java or C, it can be a constructor element. So for example, we have a class called rectangle with variable with height, function set width, function set height, and function get area. So when you use it, when you want to use the class, all you need to do is to declare a variable as cRectangle, which is the name of the class, and followed by, after that, you can use the function getSetWidth and getSetHeight to set the width and height of the class. And this setWidth and setHeight will actually set the new width into the width variable and the height into the height variable. When you use the getArea command, you will actually get the width multiplied by height as the value of the area. So this is an example of a simple class. Alright, now we talk about accessibility. Previously, in constant, in variables, even functions, you can actually put the keyword accessibility in front of the declaration of the function. Accessibility is actually level or scope of the function or variable being declared. There are 4 different values that can be put in place of the accessibility keyword, namely private, public, global, and protected. These tables will show and illustrate the difference between each and every accessibility keyword. When you declare the variable or function as private, the variable or function can be accessible within the module or class. But however, when you want to access the function or variable in an instance is actually in a controller. For example, an instance is actually a device, or a device with execution capability and the ability to run CVC. So inside that device, the entire device will be called an instance. So within the device itself, you may create many modules or class. So some functions may require you to call certain modules or class within another module. Let's say you created a module A, and you created another module called module B. And when module B tries to call the functions from module A, and the function is being declared as private, you will not be able to access the function inside module A. Similarly, when you want to do access in the entire project, meaning that there can be many instances. Maybe you have a touch panel, you have a controller, and you have another touch panel, and you want to access programs and code in another controller or touch panel, you will not be able to access it if the function or variable is declared private. And when you declare the variable as private in a class, when you declare the function as private in a class, when you inherit the class by using the inherit functionality for the class declaration, you will not be able to see any variables or functions that is created as private. Alright, so next, let's look at the public accessibility keyword. When you declare a function or variable as public, so you can actually access it within the entire module, and you can also access it cross-module within the same instance. But however, you cannot access it across instances, meaning that a touch panel cannot call a function or module that is public in a controller. And when you declare a child class inheriting from the parent class, you can actually access the public function declared in the parent class. For global accessibility keyword, you can access the function or variable across all scopes, all levels. Finally, we come to the protected keyword. This keyword is very special and is used only in a class. Alright, it shares similar capability as the private, except that in the child class, in the case of a child class, the protected variable can be inherited by the child, and the protected function or variable can be accessed and changed by the child. But however, this will not work for the private keyword. With this, I would like to end this video.